Oh, it did. Okay. So I'm just going to keep going. I've already started this. I plan to do something different, but that's okay. I think what I'll do is cut this projector off. Okay, so we got a thing that's spinning. It's a connection. Here's essentially a piston, like a car. It's going to go either to the left or to the right. And so what we're going to do is, if this is omega is equal to 2 radians a second, somebody may ask, what's the velocity of c? And so what we'll do is we'll use these rigid links and walk down them. We know the most about A, but it doesn't matter. One of the things we know is we know that this one's fixed here. So we can work our way from C back to B through to A, or A to B to C. Oh, I got a notification on my watch that finally we're live. Wonder what happened. Anyway, I don't know. So, how do we do this? Well, we walk down the link. Here's the thing. Velocity of B relative to A plus velocity of A. Okay, now, must be on same link. I'll say rigid link. Okay, so this means I can do another one. Velocity of C is equal to velocity of C relative to B plus velocity of B. These are on the same link. What I can't do is this. I can't do this. I'll write it and then I'll erase it. You can't use this one because C and A are not on the same link. Okay, so that's something you can't do. C and A, the distance, if you draw a distance between these 2 points, it's going to change. If you draw a distance between A and B, it will never change. They're rigid. They're not going to move closer or further apart. B and C, not going to move closer apart. They're on the same linkage. These are legal. This is illegal. It is, the equation is true, but you cannot use it to find out anything. So we're not going to do that one. And so what we'll do first is I'll erase this one and I'll rewrite it in a minute, but we're going to focus on this one. So we will use this other one in a minute, but we're going to focus on that one. And velocity of B is equal to omega cross R B to A plus the velocity of A. We look at the velocity of A and we find out it's 0 because it's fixed to the ground. The ground or wherever. It's fixed to wherever. It's fixed to the ground or the part of your engine that's the engine part. It's stuck there. Now, here's a crucial thing. I've kind of did not do it, but here's the deal. This is positive, and this is positive. So this is actually, from a vector sense, this vector, omega A B, in a vector sense, is 2 times K, because it's rotating in a positive direction. So I can simply write this down. In the book, he doesn't write the subscript, but I should write this. It's just the link AB. So someone could write BA, it doesn't matter. It's still that linkage. So the velocity of B is going to be, I'll do I, I'll do J, I'll do K, and then I'll write omega, 0, 0, 2, and then I'll write this. And so now I just go over and pull that. So I pulled that, put it over there. Did I bring? Yeah, I did. So now, what is that? Okay, so it's I. You do a cofactor expansion, you get a 0, 2, 5, a 0. It's J, take that out, you get 0, 2, 5, and 0. And then K, then you get 0, 0, 5, and 5. Makes sense that there's nothing here, but now we got to do this. This times this, minus that times that. So minus 10I, okay, hang on. And this times this, minus that times that. Now this is a repeat because there are two of these. This and this one won't repeat unless you got the same number here. So, okay, so again, plus and then a minus. But then there's another minus, so I get 10J. Now, let's see if this makes sense. I'm redrawing the link. So if it's spinning like this, about this location, makes sense that out here it would look like that. It would be positive y component and a negative x component. And that's what I get. And the next thing is, and this is what I like to do, is I stare at just this portion and then I dot product it with that. So a minus 10 times 5 is minus 50. A plus 10 times 5 is plus 50. And it's 0. So my dot product checks. In other words, my velocity of B relative to A dotted with R, which I don't know why I wrote B, but I meant to say R via A, by definition, must always be 0. And we talked about that the other day, that if I had a vector C is equal to A cross B, and C dot A equals 0, C dot B is equal to 0, because this vector, by definition, will be perpendicular to both those two. And so this is the way you can check that. You can look at this, look at that row, say, okay, looks like it's good, it's gonna, and you just go on. So I've checked it visually, I've checked it mathematically, and I feel comfortable about that. So now I've kind of squished up everything. So what I'll do, I didn't put a subscript here, I should have put a subscript. I'm going to copy this up to here, and then I'm going to do the second link. So what this is if you want to label the links, say, this is I worked on link 1. I got all the way down to the point where I could tell you what the velocity of B is at this drawing instant. So I'm going to go ahead and redo this and say, okay, 10, why did I write 5? Minus 10I plus 10J. So there's that. I'm going to write that up there, and I'm going to hold it, put it in a holding pattern. And instead of doing link 1, now I'm going to do link 2. And to do that, what I'll do is change the subscript, C relative to B, and then B. Now, what's funny is I have B from the last one. C, omega. Okay, it depends on how you want to do it, but you can do BC. And then here, I got to match the sequence here. And then here, velocity of B. Now, go ahead and get rid of all this and kind of get rid of, well, I can keep that. They always have this sequence. And then I'll say velocity of B. Now, I can insert it here or here or here, or wait one more step. Now, this velocity, I mean, this omega BC, I don't know it. So I do not know omega BC. I know if this thing is spinning up, if you're sitting here, it looks like this rod will be rotating. But I don't know its value. So, and I'm going to assume it to be positive. I know it looks like it's going to be going negative, but it should come out negative. So, omega BC. Now, I'm looking for my vector that's drawn from B to C, and it's 8 minus 5. And I could go ahead and insert this, but I think in order not to distract us too much, I'm just going to leave it as a symbol for a minute. And this will be velocity of C. And the reason I'm not going to deal with this right now and this right now is I'm focusing my attention on this. Because this is the new thing. That's just adding apples to apples. So this is the new thing here. So if we look at it and break it down, I get this minus J, and then I get this, and I'll go ahead and put the K, but the K renders us with nothing. There's no K component, so this dot product, determinant's going to be 0. So I'm focusing primarily here. I'm ignoring and carrying these terms right now. So I'm ignoring this and this for the moment. I'm just focusing in on this part, which is the velocity of C if you were sitting on B. I'm just focusing in on it. The others are there. But, okay, so plus this times that, minus this times that. Was already a minus, so it'll be 5 omega BC I. This will be plus, this times this minus, but I got another minus. So I get plus 8 omega BCJ. And I get nothing there. Now, let's draw this link. I'm redrawing the link. Here's B, and here's C. There's this link. It is if you look at it, sounds weird, but if you were sitting on B and looking at C, you would see this velocity. So I'm going to pin it, and then I'm going to say I've got a positive omega BC, because I assumed it to be positive. When I assumed it to be positive, this is what I did. So I get a vector which is positive in the X and positive in the Y. And I get a positive in the X and a positive in the Y. So visually this checks. Okay, I'll repeat myself. Okay, with these two terms, which actually were 3, which came from right here, so here. All of this is the same. This is the velocity. Each is written over and over. I got the first symbolic, second the mathematical, then the terms expansion, and then the value. But this, in fact, all of these things in this box are the velocity of C from the perspective of someone that is sitting at B. So what I did is I said, okay, well, it's as if this is sitting still. I know it's moving by this, but it's as if this term that is circled is as if you're sitting on B watching C. It's not getting closer or further from you because it's rigid. It's only rotating around you. I assumed it to be positive, even though I do not know its value. I assumed it to be positive. Therefore, it's rotating this way because that's positive. If it is rotating, it has a positive X component and a positive Y component. The next way to check is to dot this vector. I'll take this term, I'll multiply it times that term, and add it from this term to that term. So if I take 8 times 5, omega BC, and I add minus 5 times 8, omega BC, I get 0. So both of those check. So I feel comfortable that what we have is what we should have at this point. And now I've got to put V here. So now let me address that. Now that I've addressed the relative motion, let me address the entire equation. First, I know C only moves to the left or right. Because it's a piston, it basically only moves to the left or right. Therefore, I'm just going to say, I'm going to assume it to be to the right. I may be proven to be wrong, but I tend to always, if I do not know the answer, I tend to follow this for my positives and negatives. So if it's if I do not know it, I will assume it to go down the positive axis, or up the positive axis, or in the positive rotational direction. I don't try to guess which way it's going to go, because if I do that and I'm working these confusing problems, I've got to remember every time I assumed it differently. This way, I always assume it that way to make it so that as I work more and more problems, I have a standard that I follow. So then I'll put 5 omega BC I plus 8, and I'm just copying this, BC J plus, now I'll borrow my thing. Okay, here, minus 10I plus 10J, and I've got an equation. And I can break it into its two components. Now I actually have two equations because I have two independent coordinates. And the I can pull all the coefficients of the I, and then I can turn around and pull all the coefficients of the J. VC equals to 5 omega BC, and then minus 10. The J's are in the green, and I get 0 on the left, and I get omega 8 omega BC plus 10. So from the bottom one, omega BC, I move the 10 over, it becomes a minus. I get minus 10 over 8. So in fact, my initial assumptions verified. I assume it. I mean, I'm not going to assume a direction. I'm going to assume it to go in the positive direction. But my gut told me as this comes up, it's going to be rotating this way, which is the opposite of that way. And in fact, the minus sign proves it right. Now, many times in the book, many times when you see people work these, they assume a direction and then they say it's negative, it was not the direction I assumed. I don't like to do that. The reason I don't like to do that is as you work more and more, there are more chances of you stumbling based upon which way did I assume it this time. So I always assume it in the positive direction, and it saves me to have to think about it. I can make my interpretation, but a lot of times mathematics will trick you, or your perception will trick you and the mathematics will help you. So I just assume it that way. I always do it that way. So in fact, omega BC is minus 10 over 8. Now I can stick that into this equation, and the velocity C is equal to 5 times minus 10 over 8 from here, and then minus 10. So that becomes a number, and it's a negative and a negative. So again, I assumed it to the right, but the negative means it's going in the opposite direction. And so it is sliding back. So you would expect that as this swung up, this will be rotating this way, and this will be sliding back.
Where did you get the negative 10 over 8?
Oh, right here.
Is that just given?
Well, in other words, I solved it right here.
Okay, fair enough.
Yeah. So I had two equations and two unknowns. It can be complicated because there can be another value here, which Okay, this is a clean one because I can solve that directly. Sometimes you might find, something like, 2/5 VC and 3/5 VC here. And then you're like, oh no, I got two equations and two items, I got to create a matrix and solve it. Does that kind of make sense? If it does, I may do something wild and crazy and then immediately go into the next section and show you another way you can do with velocities, but you cannot do this with accelerations. So first we're going to do velocities, then we're going to do instant center velocities, then we're going to do acceleration. Accelerations can be hairy, it'll take quite a bit. So I'm going to try to figure out, of course we're going on break starting tomorrow, so next week I will try my best to figure out how to maneuver my way through all this junk so that I may bring my cable and sit out there and project it on the screen so I can produce a decent lecture. If you see the old lectures I produced, they're much better than the ones I'm producing now. Plus I'm in it, so that's a distraction. So does this make sense? So what I'm going to do is I'm going to what is that number? Okay, so I want to try to come up with the number because I'm going to also try to find, clear, 5 times 10 is of course 50, 5 by 8 is, and then plus 10, 16.25. So what I'm going to do, there's another whole way to work this. Okay, I get, the velocity of C is to the left, and its value is 16.25 or 7.25. And then I got omega, might as well do that. 8 is 1.25, and this is omega BC, 1.25, and it is rotating not that way, but the other way. It's rotating this way. And so I'm writing these answers because in a minute, I'm going to do this a completely different way. Okay, so I think the thing is streaming. Let's see. So that all this will be written on the board, and that it didn't send me a notification. So, okay. Having trouble. Give me a second. Come on, man. Yep, it's all there. Okay, so it's all there online, so I'm going to erase it all. Okay, I got my things that are stored here, and I'm going to do this problem completely different way. When you have a chance to do them two ways, you should do the best you can about using that. Okay, so this premise is on this. This is a method that's premised on this. Say you had a rigid link. Obviously it's odd looking. And then you had 2 points on it. And this one's going this direction. You know the direction, okay? And then you say this one's going like this. Okay, if you knew that, where does it appear to be rotating about? Okay, yeah, okay. But there's a point that's common to it. It's called the instant center. So if I actually erased this part and said the whole linkage looks like this in my mind, because you can visualize anything. You can make up anything you visualize it. Believe me, I've seen humanity, it visualizes everything. Here's like it's rotating about that. And it turns out, if you take a perpendicular, it's just a simple process. Draw a perpendicular to 2 points that you know the direction. You don't even have to actually know the magnitude. You just need to know the direction. That's it. And then you look at it and you're like, hey, this appears to be rotating about that point. So the key is to find the instant center. It's such a simple thing. You basically draw a perpendicular line to two known, here, wait, let me stick that in there. The two known velocity directions. Now, what's funny is I assumed them to be going this way. It could have turned out that the thing, if I work the problem, it goes this way. Both velocities flip, but they're still both perpendicular. So let's use this concept to work this problem out. And I'm going to try to doctor up this thing a little bit. And I'm going to try my best to use the board space I've kind of got. Okay. I'm going to try to keep these. Okay. So this one's easy. If it is rotating like this link's instant center is always A. It's pinned there. So this velocity is perpendicular to a line here to here, and we already knew that, so there it is. Now, I can find its value. Okay, what's the length of that? The length of that, 5 squared plus 5 squared. Wait, that and that. And 25 sets, shoot, okay. And it's the square root of that. Okay, and then times omega. So the velocity, did I ever find? I never actually found the velocity of B. I found it in component form. So, if you look at it, the velocity magnitude at this point B is equal to 2 times the length of that. Okay. And so, if you look at a vector that's 10 and 10, then the length of it is 10 squared plus 10 squared, and then the square root of it. Well, I'll eventually need to know this, so I might as well do that. Okay, so give me a second. Okay. It's 50, so it's a square root of 50. And I know you could write out this thing, and then times 2. I know you could write out this thing, but I think I'm just going to, velocity magnitude here at B is 14.142. So I may not get exactly the same thing. I might get 16.255 or something, because I'm going to start truncating a few numbers along the way. Okay, so I know this one's direction. I actually know this one's magnitude. But I also know this one's direction. And here the thing is it doesn't matter whether it's going to the right or to the left. If I draw perpendicular to it, oh, here. If I draw a perpendicular to it, where this is the perpendicular, and just extend that line off, and this is weird, this one's weird. I draw a perpendicular to this, and extend that line off, this link appears to be rotating about that spot. And to me, it looks like it's rotating that way, because I do know that one's direction. It is as if now I'm making a blob. Here's my blob. Just imagine this is a big blob that is a rigid body, the green rigid body, doesn't exist except in your mind. And it's essentially this little link is welded to the green body. And so there you go. Somebody welds it to the green body, and you're looking at the green body rotating about that point at this instant. So now, if I could find this distance, say the distance from B to the instant center, and this distance D, distance C to the instant center, I can basically figure out this omega, and then I can figure out this velocity. So let's use I'll identify my geometric skills as subpar, but that's okay. So I got a triangle that sits here. It's 8, this line is 45. So if this line is 45, hang on. Okay, if this is 8, and this line is 45 degrees, because it's 45 because that's 5 and 5. And so yours might be different. They might give you the angle. But anyway, I need to know the distance from here to here. If I have 8 and a 45, I think, let's see, that means this thing, the distance to B to the instant center has to be square root of 2 times 8. And that's because that cosine and sine is, okay, so in other words, cosine of 45 is equal to the 8 over distance B instant center. But this thing is 1 over square root of 2. So move this over here, move that over there, and I get that. So now, again, I'm sorry, I probably will lose some digits. And if I do, that's just the way things are, I guess. Okay. So square root of 2 times 8 gives me that distance appears to be about 11.314. Now that's the first time it's actually 3.7, but I'm throwing it away. Now, if I want to know this omega, this is the omega of BC. Omega of BC is that length. Okay, so in other words, velocity of B, its magnitude is equal to omega BC times the distance from B to the instant center. I keep doing that, kind of fun. So if I want to know this, I take that velocity, which again, I'm sorry, I truncated a few, and I divide it by that. Now let's see. It should turn out to be okay. I know it's going to be a little bit off because I threw away some digits. 1.24995. However, if you look, it's the same thing. Now, how do we find the velocity of C? The velocity of C sits on the same green rigid body in which the link is welded to it at this point in our minds, and it's spinning about this. So the velocity of C magnitude is equal to the omega of the BC that we just found times the distance from C to the instant center. Okay, now, if this is at 45, this is 8, that's 8, and this is 5. That means this distance is 8, this distance is 5, because that was the 5, 5, and this is the 8, 8, this is 45, so that's 8. So that means this distance, it becomes, is that 13? Times, I'm going to cheat and say 1.25. But if I truncated that, it would show up as that. So, times 13, oops, okay, is 16.25. So the magnitude of the velocity at C is 16.25, the same thing we found out there. So there are two completely independent ways. Now they're dependent in the fact that they all relate to the same mechanism. They're completely independent in their approach. This is a vectored approach, and this is a instant center type approach. Both of them come with the same answer. You have to be careful of how you put your drawing together, and that's pretty much it. So that covers most of that, and we made it just to the end of the period. I'm sorry things goofed up to start with. When the technology goofs up, I go through a combination of disgust. I no longer go through anger anymore. I go through disgust and like, okay, there's not much I can do about this. So.
Where do you get 13 for the DC IC?
Oh.
Yeah, 13.
Oh, this, wait. Okay, so I flipped it. Sorry about that.
Okay.
So this was the 13, and that was that. Sorry about that.
Yeah, but where did you get the 13? Where is that directed?
Oh, okay. So the 13 comes from the distance from here all the way to here. And since this is I hate to mix my, does that make sense?
Yeah, that makes more sense. Yeah.
So this is a 45, so that's got to be the same 8 over here. Gives me 8, and then I knew that jumped up 5 because, and I should have said it, the piston's at the same level here.
So, okay, yeah. Okay.
So the sequence on all these is exactly the same. With this, and this is a key right here, is to know how to find the instant center. If you can adequately find the instant center, some people find this to be an easier way to do it. Believe it or not, if you have a CAD package and you just draw these and draw perpendicular lines and then do where do you call it, where you do a dimension from here to here, dimension from here to here. I've done that many times and it comes up with the same answer. So if you don't want to do the geometry, you can just drop it into CAD real quick, do dimensions and go with it. And it just works. So
I like the visual approach.
yeah.
Yeah.
Some people like that, some people like the other. Unfortunately, the visual works with the velocity, but in accelerations it doesn't work.
It doesn't apply.
Yeah, and the reason it doesn't is because that centrifugal part. There's
Yeah.
a centrifugal part that has it. You know.
That's pretty cool, man. Get another way.
All right. Well, again, I apologize for my 5-minute technology disgust.